This brief demo video aims to demonstrate how MDAST works in terms of estimating policy outcomes for a specific example. The objective of this exercise is to examine the impact of IRS indoor residual spraying coverage and frequency on several policy outcomes. Let's assume that there is no IRS done in the target area as status quo and set three policy alternatives. First alternative, 70% coverage, 1 round per year. Second alternative, 70% but 2 rounds per year. And third alternative, now increased to 90% coverage and 2 rounds per year. And also you can set up the other parameters such as time horizon, here set as 10 years, and also population size can be adjusted based on your target area. Note, here in this example, units are 1,000 of people. And you may want to set up the other parameters such as malaria burden and economics. And also assume that there's no other intervention such as LLIN, large sighting, and disease management. So based on these scenarios, this is a summary of the three alternatives compared to status quo. And once you run the model, you can fill out this table of result on 4 specific outcome values. So here you can set the time horizon first as 10 years, but you can change whatever you want. And let's click population section, and you can adjust the population size by age cohorts by clicking edit table. Here there is a default of 51,000 children and 246,000 adults and 30,000 pregnant women. And also you can adjust the other parameters such as malaria burden and economics, but for this specific exercise, let's keep that as default. Now, let's click the control portfolios. Okay, if you click the vector control button for current intervention, you see that there's 0 coverage and 0 rounds per year for IRS, and for insecticide type, it's alpha cypermetry. Now, you can click the vector control button for the first alternative, same insecticide, but now you can change by clicking that button. Then you see all the choices. So click 0.7, 70%, and 1 round per year. And then for the second alternative, look at the same insecticide, but now same coverage as the first alternative, but twice per year. The last alternative, you can increase coverage to 90% and twice per year. Now you're ready to run the model for a specific outcome variable. Let's click the malaria burden outcome. So let's first run the instance of malaria in total population. Let's click this CALC button, and it will compute. The model will show you how this outcome variable will change over time, over 10 years, as you set. It usually takes about 20 to 30 seconds before you see the result. Okay, this is the graph of malaria instance in total population. And red curve indicate status quo, and blue curve indicate first alternative, and green for second alternative, and orange for the third alternative. And you can do the same thing for the severe cases and also malaria treatable death. But now let's focus more on the DALI measure and also the avoided measure. So let's click the discounted DALI value lost due to malaria. Okay, now you have the 10-year total for this outcome variable. Then now you can write down the values that you got here in this table. So for the status quo, DALI lost due to malaria are estimated as 144,600 life years. And for first alternative, that should be 113,000 life years. And for second alternative, there's 84,570 life years. The last alternative is 66,130 life years. What about avoided death? And here, you click this, and you can also see the result, and you can fill out the table here. So compared to the status quo, the first alternative, the avoided malaria death are estimated as the 212.3 death with the first alternative, and with the second alternative, there's 384.5 death are avoided, and with the third alternative, and 490.2 death are avoided with the third alternative. And lastly, you can click the projected cost section in the result and pick one cost-effective measure as program cost per severe case did averted. Okay, now you got the values and fill out this table here. So with the first alternative, there's a 336.6 severe cases are avoided due to the first policy alternative, and 372.7 severe cases are avoided compared to the status quo, and 368.7 severe cases are avoided compared to the status quo. For this specific variable, you shouldn't multiply that by 1000 because this is a per severe case measure. So now by looking at this result table, then you will be able to compare the policy outcomes on the result values across the different policies with the status quo.